Alright, and now we're going to do Chapter 4, Section 2. So remember, we've already looked at congruence, definition of congruence, and then CP/CTC. Remember, corresponding parts of congruent triangles are congruent. Okay? So it's the parts that are congruent. Like a side is congruent to another side of a triangle. Okay? Now that stuff, remember, congruence applies to all kinds of things, like a lot of manhole covers are the same size, same shape. Panes of glass in a window a lot of times are the same size, same shape. You reproduce a painting on a poster or something, and it's going to be same size, same shape, a lot of congruences. And we're going to see how important congruence is later. First, we're going to learn about proving triangles are congruent, so we can use that to prove a lot of things about other figures like trapezoids, parallelograms, rectangles. So that'll be important in proving, for example, when you have a rectangle, proving that this diagonal is the same length as this one. We're going to use triangles for that. And that's something people actually do when they're putting in shelving, like in a factory, and you want to make sure you have a rectangle instead of a parallelogram. It'll be easy to use a forklift to get stuff, to put stuff on and off. This is going to be messed up. The pallets aren't going to fit as well. Okay, so this is a very practical thing. I've actually done some of that before. Now, in 4.2, we're learning different ways to prove triangles are congruent. And they're saying that these things are postulates, but you can actually prove these. Okay, so they're postulate 12, which will prove, but postulate 12, it's the side-side-side theorem. So, side-side-side postulate. If we've got two triangles, and notice the sides are congruent. So this one mark and this one mark, it means this pair is the same length. Two marks and two marks means this pair is the same length, but this pair is different than this pair. And these three mean that these two sides are the same. So when we have something like this, the triangles will be congruent. And then postulate 13, so you might want to write these down, put them in notes, make flashcards. It's the side angle side postulate, and this one says whenever you have two triangles and a pair is the same length and another pair is the same length around this angle, then the triangles are congruent. Now it's important to see that the angle must be made up of these two sides. You must remember that. If we had something like that, it wouldn't work because the angle must be between the two sides. It's got to be made up of them as this. This angle is not between the two sides. So even if it was like that, it still would not work. Okay? Because you don't know what these angles are. There's other triangles you could make, so they're not necessarily the same thing. Okay? And that's what these postulates are saying, that in this case, because we don't know what these angles are, this could be a big angle and this could be a small angle, and we could still make a bunch of triangles. But this is saying that given these three conditions, it's impossible to make another triangle than this one exactly. It's got to be the same size and same shape. Okay, we could play with that in class and see that if it's not this angle, that there are other triangles you could make, different sizes, different shapes. All triangles of different sizes. Okay. And then postulate 14 is the angle side angle postulate we call ASA. And this time notice the side has to be between the two angles. So we'd have this angle congruent to that one. So we have a pair of angles, and then we have a side, and then another pair of angles. Okay, so angle, side, angle, angle, side, angle. The side must be between the two angles. The side is between the two angles. Okay. If the side is somewhere else, this does not apply. You need to remember that, memorize that, get into your thinking. The side must be between the two angles. Notice this angle here has this side, and this angle here has this side. There's no other way this will happen. All right, and then you're using these things in the exercises. They'll check to make sure that you can recognize this and this in contrast to the other things I was pointing out. So if you try page 123, exercise 1, if you look at that, see what you think it is. Number 2, number 3. Okay, if you can stop the video and try those. I'm going to tell you the answers right now though, so you can stop it if you don't want to hear it. But the answers are, number 1 would be yes, number 2 would be yes, number 3 would be no. So just making sure you can apply the theorem properly. And then that's going to be done on some of the other exercises. Okay, and I'll stop there, and then I'll make another video proving these instead of just stating them like as the book is. Alright, cool.